All right, we are live. Now we can see if we can get anyone to join. Give me a moment. Hello, folks. Oh, we got 3 of you in. All right, I'm just updating in the classrooms, putting the stream link for people in case they can't find it through YouTube. So once that's up, we should be good to go. Post this into both classrooms. Post. Okay. Welcome, 4, 5. Excellent. Getting there. So my apologies, the internet dropped. Not sure entirely why. That has not happened before, so hopefully it will not happen again. I did an hour-long stream with my grade 12 class this morning, and it worked all the way through. So I'm hoping that we will be stable now, and we're going to get started. So the presentation called Solving Equations with Difficult Fractions is the one I'd like you to take a look at. We're going to be looking at slide 11, and it has the equation x over 4 equals. So that's where we're going to start. And this is actually an equation that we can solve very easily with the techniques that we've already done. We've actually solved equations like this, but it sets out the main idea for how we are going to solve more complicated equations, and so I wanted to go over it. So the basic idea here is that we want to get x by itself so we know what it equals, but right now instead of just x, we have x divided by 4. And since it's a division, the opposite operation is a multiplication, and so we can use the opposite operation to undo it. So if we have x over 4 times 4, and I'll do it like that, then that's going to undo the division by 4. But of course, whatever we do to one side of an equation, if we want to keep the equation equal, we have to do the same thing to the other side. If this tree gets 4 times as tall, then this tree needs to also get 4 times as tall for them to still be the same height. So at this point, we would usually just cancel the 2 4s and write x here. I'm going to show you an extra step, which is I'm going to do the multiplication. So I'm going to make 4 into 4 over 1. We have 2 fractions here, so we can go top times top, bottom times bottom. We'll get 4x over 4 equals 12. And then we can do 4 divided by 4 is 1. So we're left with just x equals 12. And as always with these equation solving questions, we can check whether we have the right answer very easily. We just take our answer and put it into the original equation. So if I put a 12 here in place of the x, 12 divided by 4 is 3. This side is also 3, so I know that I have the right answer. So I'll pause for about 10 seconds there and just let you ask any questions that you have about that, and then we'll slowly work up to more difficult ones to do together. If you're typing questions in the chat, it's helpful to just put the word question as its own comment and then hit enter and then start typing your actual question. And that way I know that someone's about to ask a question, and so I can wait and you'll have enough time to type it. But it looks like we don't have any questions so far. So we're going to move on to the second example from the slideshow. And so this one's starting to get a little more complicated in terms of how it looks, but not much more complicated in terms of how we need to solve it. So we have x plus 2 over 4 equals 5. This is slide 12 in the slideshow. And we're going to do the exact same approach. So we're going to say, okay, we have a fraction. We don't want to have a fraction. How can we get rid of this fraction? Well, the fraction has a divide by 4. So we can undo that by multiplying by 4 on both sides. And so here we need to be a little bit careful. We could definitely just cancel the 2 4s, and that's totally valid. But I want to walk you through more detailed steps of that, because in a moment we're going to see equations where we won't be able to cancel quite as simply. So one way that we can do this is we can go, okay, 4 over 1, making it into a fraction, times x plus 2 over 4. This side, 5 times 4 is 20. And now we can do top times top, 4 times x plus 2. Brackets here are really important, because if I forget to put brackets, I'll probably just do 4 times x and forget that the 4 is also multiplying the 2. So I really strongly encourage you to put the brackets here. It will help you to avoid errors. Bottom times bottom, 1 times 4 is 4, and that's equal to 20. And now we can do 4 divided by 4. We get x plus 2 equals 20. And now this is a typical equation that we can solve with our previous techniques. So I'm going to subtract 2 on both sides to get rid of the plus 2, and I'll have x equals 18. As always, we can check, is our answer correct? Well, let's put it back into the original equation, which didn't have these 4s. 18 plus 2 is 20. 20 divided by 4 is 5. And so now both sides work out to 5, and we know we have the correct answer. What questions do you have about that so far? Okay, I'm not seeing anyone in the chat saying that they have a question. So we'll move to the third one. So this is, again, in the presentation, this time slide 13. We have 4x plus 7 over 5 equals 7. And this one doesn't require anything new. So I'm actually going to ask you to try this one out and see what you can do with it. Are you able to solve this one using the techniques that we have? Hey, Jackson, good to see you aboard. Thanks for the what's up in the chat. All right, so I'll give you maybe 30 seconds or so, 40 seconds to give this one a try. Once you get an answer, if you can just type into the chat and let me know what you got as the final answer for X, and that way we'll be able to check against each other's work and see whether we've got it right. So give it a try now. All right, I see there's someone just joining in now. So we've talked about two different types of two different equations, and people are trying this one on their own now. While I give them a chance to finish that up and put their answers in the chat, I'll just walk our new joiners through these two equations here so that you can catch up with the stuff that we've already done. And again, my apologies for the interruption at the start. My internet dropped. I think it's working well now. So we looked at x over 4 equals 3. We said, hey, this is a division by 4 that we want to get rid of. So let's undo it with a multiplication by 4. So we multiply both sides of the equation by 4. 4 is the same as 4 over 1. We can multiply the fractions, top times top, bottom times bottom. We get 4x over 4 equals 12. 4 divided by 4 is 1. 1 times x is just x. And we have our solution. And so the main idea here was to multiply by the denominator to make the fraction go away. We did the same thing for this one. Multiplied both sides by the denominator. Need to make sure that we have our brackets here on the x plus 2, so that remember 4 is multiplying all of the x plus 2. And then we can cancel out. 4 divided by 4 is 1, leaving us with x plus 2 equals 20. And then I subtracted 2 from both sides to finish up and get the correct answer. And as always, we can check that answer by substituting it back in. 18 plus 2 is 20. 20 divided by 4 is 5, which is what we have on the other side as well for the original. All right, so hopefully you have a chance to try this one out. Once you get an answer, please just type it in the chat, x equals whatever you think it is here, and we'll go from there. Let's see. Thank you, Jackson. So we've got one answer. Other people are getting them, whether it's the same as Jackson or different, feel free to just type it in there. And that way I know that people have had enough time to do the question. Thank you, Aiden. Good to see the 7 up there. Thank you, Nina. Good to know, Aiden. I'm sure Jackson will be very upset. Thank you, Emma. So we've got 4 answers. I'm going to see if we can get one more to get us to halfway out of the 10 people in the chat. All right, it looks like no one's biting on that. So we've got 7 as the answer. Indeed, that's correct. If we multiply both sides by 5, we'll end up with 4x plus 7 equals 35 after a couple steps, and you can work it through from there. So x equals 7 is our correct answer for that one. Okay, so now let's dig in for one that's actually a lot more complicated. And this one is the last one in the slides. I'll write it out here. Let me just make sure I'm in your visible area. Yep, okay. So we have x plus 1 all over 3 plus 2x minus 3 all over 5 equals 6/5. So here you can see things are starting to get more complicated. We have not just one fraction, but 3 different fractions. 2 of them are on the same side, and they don't all have the same denominator. So it turns out that we can handle this question without too much trouble by using the same idea, which is multiplying by the denominators. But there is a little trick we can do to speed things up. So I could multiply everything by 3. And when I do that, this first fraction is not going to be a fraction anymore. It's just going to be x plus 1. But these next 2 will still be fractions. So then I would need to multiply everything by 5 to make these 2 fractions go away as well. But the trick is that I can combine this all into one step, and I can say, okay, I want to get rid of the fraction with 3 denominator and 5 denominator. What's the common denominator for 3 and 5? Like if I was adding these and I was trying to find a common denominator, what would I do? Well, I'd go 3 times 5 and I get 15. So I can just multiply everything by 15, and that's going to make all the denominators go away. So let me show you an example of that. I'm just going to move this up a little bit. So 15, I use them is because we're going to have some regular brackets as well. And so it helps to be able to distinguish the two. So multiply this whole side of the equation by 15 and multiply this whole side of the equation by 15 as well. So everything's multiplied by 15. Now we know if we're multiplying a sum or a subtraction that's in brackets, we have to use distributive property. So 15 is going to multiply this first term, and 15 is going to multiply this second term. So 15 over 1 times x plus 1 over 3. And I'm going to put my brackets right now to make that a little easier. Plus, distribute the 15 over 1 over this side times brackets 2x minus 3 all over 5. And then on the opposite side, I don't have to worry about distributivity. I can actually just do the calculation. So 15 times 6 is 90. 1 times 5 is 5. And you might have pre-reduced this ahead of time. 15 divided by 5 is 3. If so, then you already know that 90 divided by 5 works out to 18. All right, so now we're in shape to deal with each of these fractions over here. So I'm just going to multiply top times top, 15 times x plus 1 over 1 times 3 is 3, plus 15 times 2x minus 3 over 1 times 5 is 5. Now people will usually skip this step and go straight to this current line. So they'll do this step and then straight to here. So you're welcome to skip this step. The reason I show it is that if I go from here straight to here, a lot of times students are like, wait, how did you do that? And so I wanted you to see this part so you understand why this turns into this down here. So now we can go, okay, 15 divided by 3, that's 5. And it's still times x plus 1. And then over here, 15 divided by 5, well, that's 3. And it's still times 2x minus 3 equals 18. And so now you can see the benefit of doing this. We took an equation at the top that had lots of fractions in it, and we've turned it now into an equation that doesn't have any fractions in it. And all we needed to do was to multiply by a common denominator. And just like when you add, if you use the lowest common denominator, then your numbers are a bit easier to work with, but you can use any common denominator. It doesn't have to be the lowest one. Okay, so I'm going to pause there for a moment. If anyone has questions, feel free to type them in the chat. Give you about 10 seconds. You can just put the word question in and then type something longer so that I know that a question is coming. Okay, so it looks like no questions so far. So we're going to finish this equation off. This is just distributive property. 5 times x is 5x. 5 times 1 is 5. 3 times 2x is 6x. 3 times negative 3 is negative 9 equals to 18. So our distributive solving has come in handy here. And now we can collect like terms. 5x plus 6x is 11x. 5 minus 9 is negative 4 equals 18. And now you can see that things are as simple as the very first equations that we did early on in the first week of the semester. So let's finish it from here. 11x minus 4 plus 4 equals 18 plus 4. And then we have 11x, that adds to 0. 18 plus 4 is 22. So 11x equals 22. And then we divide by 11, and that gets us to x equals 2. Is this the right answer? Well, as always, we can check by substituting back into our original. 2 plus 1 is 3. 3 divided by 3 is 1. I'm just going to keep a little record up here. 2 times 2 is 4. 4 minus 3 is 1. 1 over 5, that's 1/5. And then this is 6/5. Well, 1, that's 5 over 5. 5 over 5 plus 1 over 5 is indeed 6 over 5. And so we know that x equals 2 is the correct answer. And we can see now that Aiden was ahead of his time in the chat there. All right. Any questions about any of that? Okay. These are pretty much the most complicated equations that we will do in grade 9. Grade 10 goes up a little bit, but for grade 9, this is as tough as it gets. So we'll do a couple more just so that you can get used to it. If you look in the document that was shared through the Google Classroom lesson, it's called Day 3, Solving Equations with Decimals and Fractions. And we'll try a few more equations out of there. All right, so here we go. So if you move over to that document, Day 3, Solving Equations with Decimals and Fractions, we'll do question A together. It's a decimals one. Decimals, it turns out, super easy. They're exactly like regular equations. The only difference is the numbers are decimals. So if I have something like this, I want to get rid of 5.84 from this side to get the y all by itself. So I'm just going to subtract 5.84 from both sides, the same as I would have if it was just the number 5, right? I'd just subtract 5 from both sides. Instead, I'm going to do 5.84 from both sides. So there we go. 5.84 minus 5.84 is 0. That leaves us with negative 2.2y. And this is a really common error. A lot of people forget that it's 2.2y negative. So the sign in front of the term, always part of the term, negative 2.2y. Okay, and then over here, 18 minus 5 is 13.6. 13.6 minus 0.84 is going to be 12.8, 12.76. And you can double check and see whether I've done that calculation correctly. Hope that I have. And finally, we're going to divide by negative 2.2. And then we can pull out calculator and check. Oh, I just heard the autofocus. Are we still in focus? Yeah, okay. And now we can check that we've done this correctly. So 18.6 minus 5.84, indeed 12.76, divided by negative 2.2 equals negative 5.8. So negative 2.2 divided by itself is 1. 1 times y is y. And so we have y equals negative 5.8. So you can see there's nothing new there. It's exactly like the other equations we were solving, except that the numbers are decimals. All right. So that was question A. Question B, we have x over 3 minus 3x over 2 equals 1 over 6 minus x. So we've got lots of fractions here. We're going to follow that same idea, find the common denominator, multiply everything through by the common denominator, and then you won't have any fractions and you can solve as normal. So for this one, we might do 3 times 2 is 6 times 6 is 36 and multiply through by 36. That will work. but it's not the lowest common denominator, so we're going to have to deal with some big numbers. So instead, I'm going to use the lowest common denominator, which is just 6. So I'm going to multiply everything through by 6, both sides. 6 over 1 times 1 over 6 minus x. So both sides got multiplied by 6. Brackets critical here. The 6 needs to multiply the whole side, both terms, not just the first term. So we need the brackets for that. So now I can do 6 times x over 3. Well, 6 over 3, that's going to be 2, so this is 2x. And then here, 6 times 3x over 2. 6 over 2 is 3 times 3x is 9. So negative 9x. Over here, 6 over 1 times 1 over 6 is going to be 6 over 6, which is 1 in lowest terms. And then 6 over 1 times negative x is negative 6x. And again, if it helps you to show that extra step in the middle here, you're welcome to do that. All right, let's keep going. 2x minus 9x, we can collect those like terms. That's negative 7x equals 1 minus 6x. I don't want an x over here. I want them all on this side. So I'm going to add 6x to both sides. Negative x plus 6x, or sorry, negative 7x plus 6x is negative x. Negative 6x plus 6x is 0, so 1's all that's left. This is technically negative 1x. We don't usually write the 1, but I'm going to divide by it. Negative 1 divided by negative 1 is 1. X is all that's left, and over here we get negative 1. Oh, and you can't see what I just did. My apologies. Let me get that back on the screen. There we go. Okay. So hopefully that gives you a good sense of how this works. I'd like to find out in the chat how many people would like to see me do question C and or question D. You can just type 1 in the chat. If you want to see me do those questions, type 2 in the chat if you feel like you're set now and you don't need to see those examples. So again, that's 1 in the chat if you'd like to see another example. 2 in the chat if you're feeling pretty comfortable and you don't want to see anything else. And now we find out that Alan is the owner. Very much appreciated. Oh, Cooper's watching too. All right. So we'll give maybe 2 more of these a try. If you look at question C, we have x minus 2 over 4 minus x minus 7 over 3 equals 1. So as I go through this one, I'm going to ask you to figure out certain steps. So for this one here, what should I multiply both sides by? What denominator should I use to make sure that all of my fractions will disappear? So take a moment, think it through. What do I multiply by in order to get the fractions to go away here? Once you have an answer, just type the number in the chat. Thank you, Nina. Thank you, Alan. Thank you, Cooper. All right. So you can see we've got people saying it's 12. We have a 4. We have a 3. 4 times 3 is 12. So 12 is the one that works. So I'm going to go 12 over 1 times x minus 2 over 4 minus x minus 7 over 3 equals, and both sides have to be multiplied by 12. So we'll do that. I guess technically I don't have to write this 12 as a fraction. I could just leave it as a whole number. Okay. So then 12 over 1 times x minus 2 over 4 plus, going to distribute again, 12 over 1 times, oh, sorry, I should not write plus there, minus 12 over 1 times x minus 7 over 3. And then 12 times 1, that's easy, that's just 12. So there we go. And now 12 over 4, and again, you can write this type of thing if you want. All right, and so if you want to write out this full line, you're welcome to do that. Instead, I'm going to just get us to the answer. 12 over 4 is 3, so this is going to be 3 times x minus 2. Here, 12 over 3 is 4, so this is times x minus 7 equals 12. And now we've cleared out the fractions. All right, so you can go ahead and simplify this one with the distributivity. So go ahead and do the distributivity. Once you have this side distributed, if you can just write in the chat what you got for this side once the distributivity is done. I'll give you about 20 seconds, see if you can give that a try. Oh, welcome. You just had someone join the chat. So folks are trying out solving this equation right now. So if you want to take a try at it, you're welcome to do that. If not, you can just sit tight. People are simplifying this out. And once they've got it simplified, they're just going to type their answer into the chat so that we'll be able to see what they got. Okay, so can you complete this line? 3x minus 6, so that's 3 times x is 3x, 3 times negative 2 is negative 6. Negative 4 times x is negative 4x. What's the last term that I need here on this line? Go ahead and type it into the chat. Thank you, Nina. All right, negative 4 times negative 7, positive 28, as Nina tells us. And so there we go. And now we can just collect our like terms and finish this up. So 3x minus 4x, that's minus 1x, or just minus x. Negative 6 plus 28 is 22, equals 12. Going to subtract 22 on both sides. Negative x, 22 minus 22 is 0. 12 minus 22 is negative 10. And remember, this is negative 1x, so we can divide both sides by negative 1. Make sure you can still see that. And the final answer here, negative 1 divided by negative 1 is 1, so just x. And then negative 10 divided by negative 1 is positive 10. And so we get x equals 10 as our final answer. Thank you, Cooper. Thank you, Jordan. All right. So a couple of things to keep in mind. One is we're really just multiplying by that common denominator. And if we do that to the entire equation, that's going to get rid of our fractions and make life a lot easier for us. The second one is that we need to be pretty careful as we go down because we're going to have distributivity to do and so on. So just take care with your steps. Stop, think about what you've got. And then the third thing is when you get your final answer, go back up to the original equation, substitute it in and check. So let's do that. 10 minus 2 is 8. 8 over 4 is 2. 10 minus 7 is 3. 3 over 3 is 1. 2 minus 1 is indeed 1. And so we know now that we have the right answer. So anytime you're doing equation solving, at the end of it, you never should have to wonder, did you do it right or not? Even on a test, you can tell for sure whether you got the right answer by just taking it and subbing it back in. All right. So the assignment work for today is to just do the remaining questions on the second page there, E through to L. I'm going to stick around on the chat for a couple of minutes and just make sure that if anybody has questions about this or about any of the other stuff that they've done, that you have a chance to ask those. But that's it for our lesson on solving equations with fractions. Thanks so much. On Wednesday, I will probably put out a little survey asking you how this went. And if you have recommendations for how to make things better or easier to learn from, please let me know. I'd be really happy to hear those. Take good care and have a good day. If you have any other questions, I'll stick around for those. Thanks for the question, Nina. Yes, I am going to do a stream on Wednesday, same time, 1 p.m. So this week, we'll probably do Monday, Wednesday, and Friday streams at 1 p.m. And then based on the feedback I get on Wednesday after the stream, I might use that to make changes for Friday or maybe for next week. But if people tell me that this is working well for them and they like it, then we'll probably just keep it the way it is. But yes, Wednesday, definitely 1 p.m. there will be a stream. Okay, sounds like there aren't any more questions. So thank you folks very much, and we'll see you all on Wednesday. Take good care.